If water is life's #1 requirement, Europa, a frozen moon of Jupiter, could be teeming with living organisms. Though Europa's composition is very different from Earth's. It has a solid icy crust up top and water down below. But believe it or not, that might be the perfect arrangement for alien life to exist. Below the icy crust of Europa, there is a large ocean of salty liquid water. The estimated volume of water in Europa's ocean is approximately 3 × 10 to the 18 cubic meters. That's twice as much water as all of Earth's oceans combined. Many astrobiologists consider this vast and unimaginably deep ocean as the most promising place to look for life beyond Earth. Europa is also pushed and pulled by the high gravity of Jupiter. This makes the moon expand and contract, causing it to heat up, sort of like when you repeatedly pull and relax a rubber band. This internal heat could be the energy source that sustains life and keeps the subsurface ocean from freezing. At the bottom of its ocean, Europa may have an active system of hydrothermal vents. These vents are like geysers that spew out underground oceanic water a few miles into space before it falls back to the surface. These vents could provide the necessary thermal environment to help life evolve. In fact, it's believed that the very first life on Earth came into existence near hydrothermal vents just like the ones that may exist on Europa. If that's the case, it would be more likely that similar vents on Europa could support and even create life. The stream spewed out by these geysers could carry traces of aquatic life with them, which could be detected by future spacecrafts as they fly right through the streams. NASA is actually designing one such spacecraft to study Europa up close. The spacecraft, known as the Europa Clipper, will fly by Europa dozens of times and will look for ingredients of life by analyzing particles of ice, water, and rock that may be coming from the interior of Europa. The massive $2 billion mission is scheduled to launch in 2023. But there is a catch. Jupiter has a huge magnetic field, and Europa is constantly bombarded with intense radiation from its parent planet. So, any biological material exposed on Europa's surface could be damaged, perhaps beyond recognition. Therefore, even if the Europa Clipper was to get samples from these water plumes, we may not find any viable trace of life. However, about 4 to 8 inches below the surface, any biological material might be protected from the intense radiation of Jupiter. So, the Europa Clipper would just have to take a core sample deep enough to confirm that Europa is home to alien life. And the life we could potentially find on Europa most likely would not be intelligent by any means, nor would it be similar to life on Earth, but it will tell us about the range of what life can be and where it can be. On Earth, life has survived in volcanic vents deep in the ocean's trenches below the penetration of sunlight. It has been found thriving in Siberian permafrost layers that are millions of years old. Therefore, extremely severe conditions of cosmic environments like the oceans of Europa shouldn't be brushed off as uninhabitable. Life may just turn up where many people would least expect.